Let us proceed with our revisions on the reinforced concrete design 1. We are comparing the analysis and the design process of reinforced concrete beam, slab, and staircase. So far, we have covered the analysis part, the design for moment, the design for the shear, as well as some parts of the serviceability requirements. Among those covered include the concrete cover, axis distance, and the L per D ratios. For more information, you may refer to the previous videos. Next, we're going to talk about the crack control for reinforced concrete structural elements. You know that the L per D ratio is a measure to prevent excessive cracking due to the bending, whereas there are also other measures that can be used to control the surface cracking of those structural elements. You know that the concrete has a low deformability. Because of these characteristics, when subjected to low tensile stress, crack can occur. That's why you need reinforcement bar to control the cracking. Excessive cracking can jeopardize the structural integrity of a structural element. Not only that, it can also affect the durability of the member. The cracking can expose the reinforcement to the environment, which subsequently leads to the deterioration of the reinforcement, and in long term, it will affect the structural integrity of that particular member. Therefore, we will need to control the crack within the allowable limits. There are quite a number of ways to control cracking. The most common one, it would be the minimum reinforcement areas, which is known as the AS-min. AS-min quantify the minimum bar area required as a percentage out of the effective cross-sectional areas of the concrete member. Normally, we calculate the AS-min after we have done the design for the moment resistance. Based on the AS required and the amount of reinforcement bar provided that we have decided, make sure the amount of reinforcement bar provided is always greater than the AS-min. You may use this formula for you to calculate the AS-min. This formula can be found in Eurocode. Whatever AS-min that you have calculated here, make sure it is not lesser than the ratio stated here. The ratio varies slightly based on the concrete grade. The higher the concrete grade, the larger the ratio. The equation here, you can get it from the Eurocode. As for the ratio here, I believe it is not found in Eurocode. Now the question here is, where do you get this ratio? Normally we see this ratio in the references of reinforced concrete design, which I believe it is obtained from the previous practices. In the applications, you have to calculate both AS-min. Use the greater value as the AS-min. As you can see here, the considerations for the AS-min based on the formula and the ratio is applicable to the beam, slab, and staircase. That means when you design the reinforcement bar for these three structural elements, AS-min should always be checked. Other than this, there is a requirement for the AS-min for the secondary rebar. the secondary rebar should have the areas at least 20% of the areas of the main reinforcement bar. In the case of the reinforced concrete beam, there is no secondary reinforcement bar. There will be longitudinal bar and deshelling, no secondary reinforcement bar, and therefore this requirement is not applicable for the reinforced concrete beam. As for the slab and the staircase, there will be main reinforcement bar and the secondary reinforcement bar. You will need to make sure that the secondary reinforcement bar must be at least 20% of the main reinforcement bar. Although the slab and the staircase are similar, but when it comes to the secondary reinforcement bar, there is still slight differences, especially when it comes to the two-way slab. Remember that when you need to design for the moment, you will need to design the reinforcement bar for the slab in the longitudinal and the transverse directions, which are the longer span and the shorter span respectively. Whatever reinforcement bar you have calculated in the transverse directions to the main reinforcement, you make sure that the requirements for the AS mean is fulfilled, and you make sure that at least 20% of the bar areas is applied. As for the staircase, normally you only design for moment in the longitudinal directions. Based on the analysis, there is no moment in the transverse directions. That means technically you do not need to design for the secondary reinforcement bar for the staircase. Such a situation is similar to the design of one-way slab. One-way slab, we assume that the load is only transferred in one direction, which is at the shorter span. That means there will be moment in the shorter span only. As for the longer span, the analysis will end up without any moment. Even there is no moment for the longer span of one-way slab and for the transverse directions of the staircase, you will still need to provide the secondary reinforcement bar. This is to prevent the cracking. And the secondary reinforcement bar is also used to keep the longitudinal reinforcement bar in position, as the main and the secondary reinforcement bar shall be tied together during construction. In checking for the minimum reinforcement bar for secondary rebar, you need to make sure the AS mean for the equations for the ratio and this 20% of the main reinforcement bar are all complied. To make it simple, regarding the minimum reinforcement, no matter it is main reinforcement or secondary reinforcement, the equations and the ratio must be complied. For beams, there is no secondary reinforcement bar. As for the slab and the staircase, there will be secondary reinforcement bar. Now the secondary reinforcement bar will have to be at least 20% of the main reinforcement bar. Next, we talk about the maximum spacing. It is another serviceability requirement that is used to control cracking. If you see the summary here, the maximum spacing here is not likely to be checked for reinforced concrete beam, but it should be checked for both the slab and the staircase. The maximum spacing is not likely an issue to reinforced concrete beam due to the limited cross-sectional area of a typical reinforced concrete beam. The common size that is used in the industry are 150 times 450, 230 times 450, and etc. When the beam's width is relatively small, which is 150 or 230, the spacing between the reinforcement bar would be quite limited. After minusing the concrete cover, the spaces for the shelling, therefore, you don't really need to check for the maximum spacing when you are designing for the beam. You may check the maximum spacing for the beam. Normally, it will end passing the maximum spacing. As for the slab and the staircase, normally you will need to check for the maximum spacing, as the cross-sectional area of the slab and the staircase are normally relatively large as compared to the loops acting onto the members. The requirement for the maximum spacing varies depending on the thickness of that particular member. If the thickness is more than 200 mm, you may use table 7.3n in Eurocode 2 to determine the maximum bar spacing. The maximum bar spacing is dependent on the stress in the tension reinforcement, where the stress can be calculated based on this formula in the functions of Fyk, Gk, and Qk. In the case that the thickness of the slab and the staircase is less than 200 mm, the maximum spacing is more straightforward. For the main reinforcement bar, the maximum spacing should not exceed 3 times the thickness of the slab or the staircase, and not exceeding 400 mm. As for the secondary rebar, the maximum spacing should not exceed 3.5 times the thickness of the member, as well as 450 mm. Next, we talk about the maximum bar size. The maximum bar size is another serviceability requirement used to control cracking. To determine the maximum bar size, you may refer to table 7.2n in Eurocode 2. Similar to the applications of the maximum bar spacing, you will need to determine the stress in the reinforcement. This formula is used to determine the stress in the reinforcement. It is defined on the basis of the Fyk as well as the ratio between the AS mean and the AS provided. The maximum bar size is likely an issue to RC beams, but not likely to the slab. The main reason it will be due to smaller effective cross-sectional areas of the beam as compared to the loops acting onto it. When there is limited cross-sectional areas and spaces to put the reinforcement bar, the numbers of reinforcement bar may be constrained. In order to have as much bar areas as possible, the designer can choose to provide large diameter reinforcement bar, such as 2H25, 2H32, and etc. It is likely that the maximum bar size is exceeded under such circumstances. Therefore, you should check for the maximum bar size for a beam. As for the slab and the staircase, theoretically you should check them as well, but they are not likely to be that critical due to relatively low loops acting onto those members as compared to their effective cross-sectional area. The reinforcement bar used is likely to be small, and if you know that you are providing low reinforcement bar, the chances of exceeding the maximum bar size is relatively low. The common bar size used in the typical slab, it will be H10, at least based on my personal experience. You can check for the maximum bar size, but it is not likely to be exceeded. As for the staircase, that may be another issue. It is possible that the maximum bar size is exceeded, especially when you deal with long span and the thickness of the staircase is relatively thin. Sometimes the bar size used may reach to H16, depending on the span of the staircase. Although there is a high chance for the maximum bar size not to be exceeded, to be safe, you can choose to check it. Next, we talk about side face reinforcement and the surface reinforcement. The side face reinforcement is provided along the side of the beam in order to control the cracking. This type of reinforcement is normally applied to deep beam with the depth of more than 1 meter. Imagine you have a deep beam and you only have the top and bottom reinforcement bar. There is a huge gap without any reinforcement that's strengthening the concrete when the concrete is subjected to bending. Because of this, it is likely for the deep beam to experience surface crack when the side face reinforcement is not provided. Therefore, you should provide side face reinforcement throughout the entire deep beam, where the reinforcement should be longitudinal to the beam span. Regarding the size of the side face reinforcement and the spacing of the side face reinforcement, you will need to do the calculations. Calculate the minimum bar areas, calculate the maximum bar diameter, and calculating the maximum bar spacing. These equations can be obtained from Eurocode 2, Clause 7.3.2. As for the calculations for the maximum bar diameter and maximum bar spacing, if you observe the formulas, you will see that the estimated stress is half of those equations that use for the calculations of the main reinforcement. Remember these two equations here? If you are using them to calculate the side face reinforcement, the calculated stress will have the Fs divided by 2, and then refers to table 7.2n and 7.3n for the maximum bar diameter and the maximum bar spacing. The side face reinforcement, it will be applicable for deep beam. Shallow beam, not applicable. You don't have to provide the side face reinforcement. As for the slab and the staircase, it is not likely an issue, as the depth of the staircase and the slab are normally not high, normally within 200 mm. To make it simple, side face reinforcement bar is not applicable for the slab and staircase. As for the beam, not all the beam require side face reinforcement. It is only required when the beam's height is more than 1 meter. Next is about the surface reinforcement. The surface reinforcement is normally associated to large axis distance exceeding 70 mm. Don't get confused with the side face reinforcement. Side face reinforcement is for deep beam. As for the surface reinforcement, it is regardless the beam is deep or shallow, as long as the axis distance exceeds 70 mm, then you will need the surface reinforcement. Remember what is the purpose of the assist distance? It is meant for fire resistance. Depending on the fire rating that a structural element is designed, the longer duration it lasts under fire hazard will require larger assist distance. Although the requirement here states that when the assist distance exceeds 70 mm, you will need surface reinforcement. You never know, in the case that you provide really thick concrete cover that leads to an equivalent assist distance more than 70 mm, you should also provide the surface reinforcement. Now, if you observe the calculations for the nominal cover, if you design the nominal cover based on the requirements in Eurocode 2, referring to table 4.4n, the largest C mean due to the durability, it will be 55 mm. Taking into account the deviations, the C nominal, it will be 55 plus 10. In total, 65 mm. Let's say now your C nominal based on the calculations is 65 plus the size of the shelling and plus half of the steel bar. It may give you an equivalent assist distance more than 70 mm. In this case, you should provide the side face reinforcement bar. Another requirement that side face reinforcement bar shall be required. It will be when your bar size is greater than 40 mm diameter. Under normal circumstances, we will not use the bar diameter more than 40 mm, unless for large member which is heavily reinforced. Don't get confused with the arrangement of the reinforcement bar for the surface reinforcement and the side face reinforcement. The side face reinforcements are longitudinal rebar being placed along the beam span. As for the surface reinforcement bar, it is normally wire mesh of small diameter, which is placed surrounding your shelling, and they should be placed below the neutral axis. The area of the longitudinal surface reinforcement bar should be at least 1% of the area of the concrete outside the shelling and in the tangent zone below the neutral axis. That means we are talking about this blue area here. The amount of surface reinforcement bar will be at least 1% of that particular area, and the spacing should not exceed 150 mm. Now, this surface reinforcement bar, it is only applicable to beam, but not applicable for the slab and the staircase. First, slab and staircase, quite rare that we have the bar size of more than 40 mm due to the relatively large cross-sectional area, and it is also quite rare to have the assist distance more than 70 mm. This can be seen from the table 5.8 of Eurocode 2 Part 2, giving you the minimum dimensions and the assist distance. These are the assist distance. Even for the largest fire rating, 4 hours of fire rating, the largest assist distance is only 50 for two-way slab and 55 for one-way slab. It is not likely to exceed 70. Therefore, you don't have to check for the surface reinforcement, and you don't need to provide the surface reinforcement for the slab and the staircase. To make it simple, the surface reinforcement is only applicable to the beam, but not all the beam will require the surface reinforcement. Only when the beam has the axis distance more than 70 mm and the bar diameter more than 40 mm will require the surface reinforcement.